threshold frequency for a certain metal is 2.5 times 10 to the 14 Hertz. What is the work function? If light of wavelength 400 nanometers shines on the surface, what is the kinetic energy of ejected photoelectrons? Well, this at the start is similar to the question that we've already solved. So we know that at threshold, the threshold photon energy, E equal to HF threshold, must be equal to the work function. So that will give us the work function directly. So let's do that calculation. H is 6.63 times 10 to the minus 34 joule seconds times, and I'm going to write it on the next line, 2.5 times 10 to the 14 Hertz, and a Hertz is a number per second, so seconds divided by seconds is nothing, and we're going to end up with a number in joules. So the work function is 1.66 times 10 to the minus 19 joules, which is of the order of an electron volt. So I'm fairly sure I haven't made a stupid mistake. So now for the second part, we're given light of wavelength 400 nanometers, and a nanometer is 10 to the minus 9 meters, so this is equal to 400 times 10 to the minus 9 meters. So we need to calculate the energy corresponding to that wavelength. So the energy of the photon is equal to hc over lambda, which is equal to 6.63 times 10 to the minus 34 joule seconds times 3.00 times 10 to the 8 meters per second divided by 400 times 10 to the minus 9 meters. Let's look at what we've got. Meters will cancel with meters, seconds with 1 over seconds, and leaving us an answer in joules. And the answer is that the photon energy is equal to 4.97 times 10 to the minus 19 joules. Okay, so the photon energy is bigger than the work function, so the kinetic energy is equal to the photon energy minus the work function, and I'm just going to calculate that directly. (3.31 times 10 to the minus 19 joules. The kinetic energy is also equal to half mv squared, where m is the mass of the electron. So just taking the last part of that, dividing both sides by a half m, that will give me v squared. So taking the square root of both sides, let's do that in stages. So, okay, I'm going to simplify what I've got written here. Just going to delete this part. Then multiply both sides by 2. Divide both sides by the mass of the electron. Square root both sides. And that gives me the velocity. Now, you need to know or look up the mass of the electron. The mass of an electron is 9.1 times 10 to the minus 31 kilos approximately. So I'll write that in directly. And then we'll compute the answer, and I'm just going to write it on the left-hand side. And we find that the velocity is 8.53 times 10 to the 5 meters per second. And we're done. I suppose I should just explain that a joule is a kilogram meter squared per second squared, so the joules and the kilograms cancel to give meters squared per second squared, which when square rooted gives meters per second. And as always, let's highlight our final answers for the ease of the marker. So that's velocity, and we were also asked to calculate the work function. Well, that was a hint as an intermediate step to get the velocity. Okay,